Hey everybody, and welcome back to another fun and exciting intermediate math class. In today's lesson, we're going to continue in lesson 10.8, and we're going to be talking about how to really kind of solve these radical problems. And in last lesson, we talked about the idea of changing them from radicals to fractional exponents. We'll be kind of talking just a little bit more about that in this lesson. So let's go ahead and jump into it. You're going to be on page 432 today, page 432. And right here, reducing a radical. So we want to take the radical and we want to do some reduction to it. We want to figure it out as much as we can, okay? So there's two different methods that we'll use. The first method, I can pretty much promise you, is going to be the easier method for you, okay? The second method is probably going to mess with your brain just a little bit, but that's a good thing, all right? So anytime that you have to figure something out and really work, you're expanding your brain's ability to think and ability to do problem solving and logical problems. So it's not like, oh, there's one method that's easy, so we'll do that, and one method that's hard, so we're just not going to do that one. No, there's one method that's a little bit easier and one method that's a little bit harder, but we're going to do both. I want you to really focus on trying to understand and comprehend both of these different methods. All right, so first method, the radical method. We want to separate each piece of the radical into separate radicals. So if the radical has a number and a letter, we're going to separate the two. If it has one letter like X and another letter like Y, we're going to separate the X and the Y. Okay, so we're going to make brand new problem with everything separated into individual pieces. All right, number two, we're going to reduce each piece separately. So we're going to take the number, reduce it. We're going to take the X, reduce it. We're going to take the Y and reduce it. Okay, so then we're going to put the pieces back together and we're going to have our solution. All right, so let's take a look at this. Let's see what this looks like. So here's my problem right here, okay? So what I want to do is I want to take and I want to separate it into individual problems. So square root of 16, square root of x squared, and the square root of y to the fourth, okay? So we've got it separated into three separate problems. Now, what I'll do from here is I'll just go ahead and separate this out. I'll solve this if possible. What is the square root of 16? Well, the square root, or what comes out of 16, is 4. How do we know that? Because 4 times 4 equals 16. Let me give you this little chart here, and I think that you should memorize this. Okay, I think this is very important for you to memorize. So if you have 1 times 1, that equals 1. If you have 2 times 2, that equals 4. 3 times 3, and I'm going to go ahead and fill this chart out so you can take a look at it. All right, so I went ahead and filled the rest of the chart in. So it goes, I'm not going to read the 1 times 1 part. So it goes 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. What is that? Those are the square factors. And here's what happens. If I do the square root of 1, it equals 1. If I do the square root of 4, it equals 2. Square root of 9 equals 3. Square root of 16, that's the one we have right here, that equals 4. Okay? Memorize that chart. Most of you already have those memorized anyways, but like commit those to your memory. Like, okay, these are the square numbers right here. So when we get a square number, like we did right here, 16, we can solve 16 out. It's just 4. It just comes right outside of the radical sign, okay? So the square root of 16 is 4. Now in this one, the letters are a little bit different, so let's kind of think through this. If the index out here is 2, and it is, remember the understood index is always 2. So if my index is 2 and my exponent is 2, when we solve it out, here's what we're doing. We're saying x times x. Okay, so this is almost like our inside. Instead of writing x squared, we're writing x times x. Well, when we have x times x, just like over here, we could have said 4 times 4, right? And what comes out is one of the 4s. So going back over here to this column over here, we have 4 times 4, all right? So here's kind of the concept. When you get x squared, you get x times x. What comes out of that is just like this. 1 4 comes out of that. Well, guess what? 1x comes out of that, okay? And I'm just going to take, and I'm going to circle the answer for each one so it's a little bit easier to see. Now, over here on this one, the y term, it's almost like we have a y squared times a y squared, okay? And what comes out of the y squared? Well, the same thing that came out of the x squared. Y comes out of that. Well, we have another one, so what comes out of that one? Another y comes out of that one. So that's what we get out of that. So now what is our answer? Everything that's circled is our answer. So we have a 4, we have an x, and we have 2 y's. Okay? Now what's a better way to write that? 4xy squared. And that would be our answer. Okay? Now, that might be like totally like mind-blowing to you, and that's okay. We're going to work on these, and there's another method that maybe you'll like better. This is just the first method, and you said, Mr. Steve, you said this was the easier method? Yes, I did. Okay, so it's a lot going on, but I think if you kind of follow those steps, you'll be okay. Let's do another one. This time we have a cube root out here. So now these numbers over here are no good to us on this one. Now we need the cube numbers. So let me go ahead and write some of the cube numbers over here. We won't write a ton of them. So 2 times 2 times 2 equals 8. 3 times 3 times 3 equals 27. 4 times 4 times 4 equals 64. 5 times 5 times 5 equals 125. We'll end there, okay? And you might have one that's bigger than this. In this one, we have an 8. So hopefully you match that up with the 2, right? The 8 and the 2, when it's cubed, go together. So here's what I would do. I would make separate problems with each thing. Now make sure that you do remember these are all cube roots out here. Whatever your root is to start with, that has to stay the same when you make your new problems. You can't just like convert that to whatever you want to, okay? So when we do this, we're going to just follow each one separately. Well, in a cube root situation, we're using this chart over here. So what is the cube root of 8? That's 2. So 2 comes outside. Well, what comes outside here? This is a little bit trickier maybe, but the same principle still applies. Here's what I like to do. I like to group them into groups that match my index. So I'd have a y cubed times a y cubed, and we still have the cube root of both of those, okay? So what comes out of this is when we have a matchy-matchy, so in other words, my exponent matches my index, and it does, then one y comes out. So a y comes out of here, but look, we have another y. So we have 2 y's that come out. Over here, we actually have a z cubed, and a z cubed. And all of these are cube roots. I'm not going to take the time to write the cube in there. So what comes out? A z comes out times a z times a z. So we have 3 z's. So our answer is going to be 2. That's that first 2. Y squared, because we have 2 y's. And then we have 3 z's, so z cubed. And that would be our answer on that one. Okay. Now, once you get good at this, you'll do all of this in your head. Like, I don't write any of that out when I'm doing these, but I do want you to write it out at the beginning just so you can get good at it, so you can remember what is going on, because that way you won't get confused. All right. Next is the fractional exponent method. All right, bring it over there so you can see it. Let's talk a little bit about the fractional exponent method. So we want to separate each piece of the radical into separate radicals. Okay, we've already done that, right? That was step number 1 of the first one as well. Step number 2, try to reduce the numbers to a power of a smaller number that matches the index. What? Okay, this is where you're going to struggle. This is the piece right here that gets most students. This is easy, this is easy, this is easy, this is like, huh? What? Step number 3, convert the radical into fractional exponents. Step number 4, reduce all fractional exponents. All right, so a lot going on there. Let me kind of get rid of this so that we can go back and forth and try to figure this out. So in this one, we want to separate, well, we don't have anything to separate. It's just x to the fourth. Second part, try to reduce the numbers. Well, we don't have any numbers. We just have x to the fourth. All right, we're on to step number 3. Convert the radical into fractional exponent. Okay, we can do that. So this equals x, and we did this in yesterday's lesson. So we have x to the, we have 4 here. So remember, 4 becomes the numerator, and this is an understood 2. It becomes the denominator. Let me rewrite that x so it's a little bit bigger there, so it actually looks like an exponent. Okay, so there we go. Now what do? Reduce all fractional exponents. So this equals x to the what? 2 over 1, or x squared. And that's your answer. And right now you're thinking, oh yeah, that's the way to do it. That's what I want to do. Love it. I told you it would be easier on the letters, right? So that is a really cool way to do the letters. And actually, you can do a combination of these two methods. So you could do this method with the numbers, because this was easy with the numbers, right? Just take that. And then instead of doing all this with the letters, you could just do the fractional exponent with the letters. You can kind of do a combination of these two if you want to, if that makes it easier. All right, so let's come over here. Now we have a number. So same thing, break it up. Well, there's nothing to break up. The second step was take this number and change it into something with a exponent. Well, that's already done for us, okay? This already has an exponent in here. So the next thing is to take and turn them into fractional exponents. So this equals 11 and 10 over 5. We're just going to reduce that, and we're going to get 11 and 2 over 1, or 11 squared. We know what 11 squared equals. It's just 11 times 11. That equals 121. That would be our answer. And you're still thinking right now, man, this is so much easier. You lied to me. I know, I know. Okay, wait for this next one. All right, here we go. First step, break them all into separate problems. So that's going to equal the fourth root of 625 times the fourth root of a to the 8th. Okay? Now, what we wanted, and this is the problem right here. This is the struggle bus, okay? So we want to take this number and we want to reduce it so that it has an exponent. All right. That's not always the easiest thing to do. So here's something that you can do is you can try to figure out, okay, what number that I know can I reduce so that it's something times something times something, and you want it to match this if at all possible. What do I mean? I want it to be some number to the 4th power. So you might try different things. You might say, and this is kind of, again, this is where the struggle happens. So if I say, what's 3 times 3 times 3 times 3? 3 times 3 is 9. 9 times 3 times 3 is 27 times 3 is 81. Didn't get us to where we needed to go. So then I could try something else. Now, I will save you the time. We don't even need to try 4, because 4 is going to give us an even number, and this number is odd. So if we do 4 times 4 times 4 times 4, that's going to give us an even number every time. So we don't even need to waste our time with that one. So we could try 5. 5 times 5 times 5 times 5. 5 times 5 is 25 times 5 times 5 is 125 times 5 is, guess what? Ding, 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 we got it, 625, okay? So, in other words, if we take 5 to the 4th power, 5 to the 4th power, and we keep the fourth root, this is the same thing. This is equivalent to this. And again, that's where the struggle comes in. Trying to get this number to be matchy-matchy with this number is difficult, okay? But if you can do it, if you can wrap your mind around it, this can be very easy for you. Now, let's take this and convert it into fractional exponent. So 5 and 4 over 4. When we reduce 4 over 4, we get 5 to the first power, which is just 5. Okay? So coming over here, we're going to do the same thing. We're going to turn it into a fractional exponent. So we're going to get a to the 8 over 4. We'll reduce 8 over 4, and we're going to get a squared. We can't do anything else. Well, a to the 2 over 1, which is a squared. We can't do anything else with it. This is our answer, 5a squared. All right, so there you have it. Two different methods. Neither method is super easy, okay? There's problems with each thing, but those are the two methods that we have for solving these. What are some keys there? Some keys there are remembering what are your perfect squares. You know, 4, 9, 16, 25. Those perfect squares are really, really important there. Another thing to remember is how to change it from a radical to a fractional exponent, okay? And then do some reducing and things like that. Again, not super easy, something to work on. Make sure you try these practice problems. Scroll the video back, keep working on it. Find the method that works for you, maybe a combination of the two methods, whatever, but keep working on this until you refine your skills here, okay? That's all I've got for you. Hope you have a good one. We'll see you later. Bye-bye.